Okay, good morning, friends, ladies and gentlemen. This morning, I would like us to look at the LED driver, the LED driver. This particular one in this particular model in particular. So this is a 100 watt LED lamp. So in this LED lamp, we have two separate drivers, 50 watts each. So the lamps are separated into two sections. Each section is 50 watts each. Yeah. And basically, before we talk more about it, let us have a breakdown of what of the driver itself. So this driver simply takes has a normal topology for every switch mode power supply, the most basic topology for every switch mode power supply, which simply comprises of we have a fuse. In this case, we have fuses on both lines, the live and the neutral. They all have fuses. 0.22 ohms resistor as the fuse, 0.22 ohms. From the fuse, the voltage is injected into the rectifier. Yeah, the block rectifier will convert the AC into DC. After which, the DC is injected via resistors. These resistors are all wired in parallel and connected to the negative of the filter capacitor. Then the other positive terminal of the rectifier is wired through a 10 kilo ohm resistor. So basically, this forms the drop-down network. The rectifier, the parallel resistors on the negative track, and the 10K resistor on the positive track, they all form the drop-down network for this driver, which helps drops down the voltage. So we're going to see the voltages as they drop down as we go further. So after the rectifier, the drop-down resistors, the voltage passes through the buck type. This is a buck type quasi resonant LED switch, or better still, a LED driver chip. Yeah, the inscription on it is KP1073. You can Google that out to see for yourself. Yeah, so basically, the dropped down voltage is injected into the chip. Then looking at this particular topology, the positive rail to the capacitor from the rectifier is injected into the chip. Then from the output of the chip, the positive rail is now injected via these diodes, parallel diodes, to the positive of this capacitor, of the filter capacitor. So that's how it is. Maybe in future I will sketch the diagram for us to see clearly. Yeah. So with that said, the next thing is this other capacitor we see here is the output capacitor. It is 400 volts, 2.2 microfarads. And if you look carefully here, you see a resistor. The capacitor is connected in parallel with this resistor. So the two, they form an RC network. Very simple RC circuit. Basically, it can be a low pass filter, things like this, low pass filter, or this DC discharge path. But for this purpose, it is a DC discharge path, or better still, this resistor acts as a bleeder. Yeah, and the time constant of the RC circuit determines how fast the stored charge will fade out, how fast the charge stored in this cap will get depleted. Yeah, stuff like this. Then from the output of this cap, we have our positive and negative, also wired through the input of this ferrite core. Thank you. Proceed later.